Good morning, ladies and gentlemen. I hope you are doing well today, and I hope this video makes some sense. We're gonna look at the homework, and really, these are these are all kind of like verbal answers, and so I'm just going to kind of talk through what we should have had. On number 5, it says y equals f of x plus 3. And the question is, what does this plus 3 do to the graph of f of x that, as compared to if it wasn't there? And the answer is real simple. When you add something on the tail end of something, it just goes up 3 units. It moves it vertically. The second part of this problem said y equals f of x plus 3, and it put the plus 3 on the inside of the function. And we know that when it's put on the inside of the function, that always adjusts it right to left. And so for this one, that pushes it to the left, even though it doesn't seem to make sense because we think left, we think negative. But remember, the right, left's always the counterintuitive. And so it goes to the left 3 units. Okay? Number 6, almost the identical problem, except they switched around. They said f of x minus 4, and then y equals f of x minus 4. And on this first one right here, because it's on the inside, that's going to adjust it right to left, or right and left. And so put that minus 4 there. It's going to scoot it over to the right in the positive direction 4 units. With this second one, having that minus 4 on the tail end, with that, we just know that we're going to drop the whole thing vertically 4 units. Okay? I can't remember. I think we did number 7, yeah? And so the problem with number 7 is that I didn't give you a ton of warning about these. These were kind of like as the bell was ringing, oh, hey, by the way. And so hopefully you looked into them a little bit. And what happens here is if you throw a negative sign out in front of everything, think about what that does. What that does is it changes the sign of the y. It makes every y have the opposite sign. So, for instance, For instance, if we were doing just a really basic, parabola that came down at the origin, and we said, okay, now take every y value and give it the opposite sign, well, then that would look like this, and it'd be down here. So really, what happens when you put a negative out front? Well, it rotates everything about the x-axis, because that's what this is, the x-axis. And then in the other one, what happens is now you're throwing in the opposite x value. And to throw in the opposite x value, that's going to rotate everything around the y-axis. For instance, if you had I'm trying to think of an example. If you had, y equals, or f of x equals x cubed, and we threw a negative out in front of that. Okay, well, it normally looks like this. And so now we're going to bring that part over here and this part over here. Okay, it's going to rotate it about the y-axis. All right, and so that's the answer to this. This one, what does it do on that first one? Well, it rotates or reflects it about the x-axis. The second one, what does it do? Well, it rotates or reflects it about the y-axis. All right, moving on. Let's see here. Okay, number 8 we did not do. Number 9 we did, and number 9 was kind of a fun problem. I say that. I know you guys are rolling your eyes. Fun. Okay, it was y equals f of x minus 5 plus 2. And then the other part was y equals, f of x plus 1 minus 1. All right? And so for this one, we go, well, whatever's happened on the inside affects it right and left. So it got moved to the right in the positive direction 5 units, and this moves it up 2 units. So those two things both happened. Again, this one affects the right and left, and so it got moved to the left to the negative direction 1 unit, and this dropped it, and that brings it down 1 unit. Okay, and then number 10, again, virtually the same problem. Y equals f of x plus 3 plus 2. And then, let's see, y equals, let's see, what's the other one going to be? Y equals f of x minus 7 minus 3. Okay. And so for this one, this moves it right and left. That moves it to the left in the negative direction, 3 units. And this moves the whole thing up vertically, 2 units. This thing right here moves it to the right, the positive direction, 7 units. And this thing right here moves it down 3 units. Okay, so hopefully those were pretty simple. I liked those problems. I thought they're relatively easy. So now what we're going to do is we're going to look at this next set. Now, I'll be honest. When I was looking at the other class's homework, not a lot. Some of the students, how about that? Maybe even half of them did just kind of really like super fast graphs. Like and now it looks like, and I'm like, that's too fast. That's too fast. I expect you to kind of, it should kind of look like what we're talking about, kind of have some expectation. So here's what I did. Okay, number 27 says f of x equals x squared minus 1. Now, that's not what this graph is. This is the graph of the standard, or not the standard, but the, what do they call it? They call it the standard function, or I've also heard it called the root function. And so I've graphed f of x equals x squared. That's what this is, okay? And then what we're doing is we're going, okay, so then what does this -1 do? Well, of course, it just drops the whole thing 1 unit. That's not very good. Let's try that again. So it looks something like that. And this part's going to get away from me. Whoa. Okay. All right. So that's what you should have. Now, you don't have to have both graphs, but there's nothing wrong with having both graphs as long as you identify them and say, okay, this one right here, that's f of x equals x squared plus 1. Or minus 1, rather. Minus 1, sorry. Okay. This next one, it says f of x equals the square root of x plus 1. Well, what I did is I graphed f of x equals the square root of x. That's what this is right here. And then if I have a plus 1 on the back end, all that does is bring the whole thing up vertically 1 unit. And so then it looks something like that. Okay? All right. And you could translate these points up here and go, that point goes here, and that point goes here, and then there's one other point that goes here. You could kind of do that. All right. Number 31. Now this one's a little bit different. It was a little bit harder for some people to see what the standard or root function was. And what the standard or root function was just y equals, or f of x equals x squared, this basic parabola. And what happened is this x minus 5 got put inside it. And so that always affects it right or left. So this gets moved in the right, in the positive x direction, 5 units, 1, 2, 3, 4, 5. And so it would look something like, and I'll try to graph it well. There we go. And it looks something like that. Okay. All right. Number 33. Now I'm getting a little bit quick on this one. Okay. Here we go. Here's the root or standard function. It's f of x is equal to the square root of x. And what am I doing? I'm adding 4 inside the function itself. So that's always going to move it left or right. And in this case, it's going to go left. Okay, so it goes like that. All right. Okay, so this is this one, and this is this one. All right. And on the home stretch. Now this one I find funny. Okay? Because having the negative sign was all about reflecting it or rotating it about the x-axis or rotating about the y-axis. So we got to go, well, which one are we doing? This is the problem that's given to us in the book, okay? This is another problem saying, what if we were given that? Well, when we're given the negative out in front, think about what that does. It makes all the y values the opposite. So it reflects about the x-axis. Whereas when we put the x and we change the sign of the x, that flips everything. It makes every x positive value negative and every negative x value positive. So that reflects it. I'll write reflects again about the y-axis. Okay? So, for example, if I was doing, say, the square root of x, the square root of x is this basic like half a parabola right here. If we wanted to reflect it about the x-axis, that would mean it would then show up down here. Oof, sorry, that got curvy. Okay, and then, or if we were doing this other one, and we were saying, okay, on this one, same thing, we'll do square root of x right here. Well, we're going to reflect it about the y-axis. That would then show up over here. Okay, just so we understand what we're talking about. Now, so this problem, it said to do this, which is to reflect it about the y-axis. Now, here's the really funny thing. Think about this mathematically. Negative x cubed would be negative x times negative x times negative x. Negative x times negative x would be x squared times negative x would be negative x cubed, which is the same thing. So this is one function where it doesn't matter which way you rotate it or reflect it. It ends up being the same. Here's my example. Okay, the one in red is f of x equals x cubed. That's this one. And the one in blue is f of x equals negative x cubed. But it is also f of x equals negative x cubed because they are the same thing. That's pretty simple. Okay? We like that. That makes sense. Let's get rid of that. There we go. Okay. Okay, so that was pretty simple. All right, and the very last one, number 37. Okay, we're given the problem f of x equals the cubed root. I'm sorry, not the cubed root, the quad root of negative x. Now, the quad root is similar to, it's not, the root function is not f of x equals the square root of x. That's not the root function. I'm just saying that those f of x equals square root of x and f of x equals the quad root of x are similar in their appearance. Okay, this one would just be a little bit more rounded on here, and it would actually take off slower. I've kind of drawn it wrong. So it would be more rounded, and then it would kind of go like, it'd be like that. Okay. So anyway, I just kind of giving you that example. So then what the root function is this one right here. And then so to put a negative x inside it, what that does is that reflects it about the y-axis. And show up over there. Okay, not great, but you get the picture. All right, that was your homework. If you got any questions about it or anything of this didn't make sense, please just kind of scroll back, rewind the video, do whatever. I hope it did. I think this stuff is pretty simple. You guys are a really intelligent group, and we're really doing well the other day. So hopefully that worked. All right, we're going to talk about our assignment in just a minute in the next video.